Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2017 Foundation Tier Paper 2. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Question 1. How many minutes are there in 2.5 hours? Well, 1 hour, as you know, is 60 minutes. So 2 hours is going to be 120 minutes, isn't it? Twice that. And a quarter of an hour, what's a quarter of an hour? A quarter of an hour is 15 minutes, isn't it? So it's going to be 120 minutes and 15 minutes together. Adding those together is 135 minutes. It's that one there. Question 2. Which of these numbers is half of a square number? Circle your answers. Okay, well let's try listing out what the square numbers are. The square numbers are 1 squared, which is 1, and then 2 squared, which is 4, and then 3 squared, which is 9, and then 4 squared, which is 16, and so on. There are more, but I think we've got as many as we need. Now, if we divide each one of those by 2, half of 1 is a half, or 0.5. Half of 4 is 2. Half of 9 is 4.5, and half of 16 is 8. So, which one of the numbers in the list is half of a square number? It's going to have to be that one there, isn't it? The 2. Question 3. Circle the value of the digit 3 in the number 17.03. Okay, so in 17.03, these ones are the tens, aren't they? And then units. The first number after decimal place is tenths, and then after that is hundredths. Okay, so you should know that the 3 is in the hundredths column, which means you've got 3 100ths. Okay, which is that one there. Question 4. The value of A is double the value of B. Circle the correct formula. Okay, let's go through each one of these and have a look then. So let's have a look at the first one. A is equal to B plus 2. So that is not double the value because B doesn't have to be 2. So it's not that one. A equals 2 lots of B. Well, that's the same thing, isn't it? Doubling B is the same as multiplying it by 2. The third one is taking B and dividing it by 2. So it's not that one. And the last one is taking B and multiplying it by itself. So it's not that one. It's this one here, isn't it? A equals 2B. Question 5a. Simplify y times y. Well, we can simplify it by writing it in an index form. Y times y is simply y squared. Okay, and then 5b. Simplify 5a plus 2 minus a plus 9. Okay, so we need to collect like terms here. So I've got a 5a term and a minus a term, and I've got a plus 2 and a plus 9. Now notice I am highlighting the signs along with the number or letter that follows them, because those two things go together. So let's have a look at adding up all the A's. Then I've got 5A take away A, which is 4A. And I've got plus 2 plus 9, which together gives me plus 11. So I get 4A plus 11. Question 6. The table shows information about the birds in a garden. So we've got different birds, robins, sparrows, wrens and larks, and there's the number of times they appear in the garden. So we've had 2 robins, 5 sparrows, 3 wrens and a lark appearing. And we need to draw a bar chart to show that information. Okay? So with a bar chart, we need to have the frequency up the side, and we can have the names of the bird along the bottom. Now this is discrete data, so our bars should not be touching when we draw these bars. You need to have a space between each one. Okay, so let's start off by drawing the axes. So I've got my ruler. Let's just draw my axes down the side and along the bottom. Okay, so there's one axis. Oops, and then along the bottom as well. Okay, now let's just check what the largest number is on our scale. It's 5. So the highest number I need to go up to is 5. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. So I'm going to use 1 block per number. I want to try and make charts as large as they can on the scale that you're given. If I could have used 2 blocks per number, I would have done, but it wouldn't have fitted in. So I'm just going to use 1 block per number like that. And then I've got 4 things: robins, sparrows, wrens and larks. And I need to fit those in. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Now bearing in mind I need to have a space in between, I'm going to write those names sideways so they fit in nicely. So robin, what was the next one? Sparrow, wren and lark. Sparrow, wren and lark. Okay, and then I'm going to draw a bar for each value, or for each bird. So there were 2 robins. Okay, so I've drawn each of my 4 bars now at their correct heights. Notice that there are gaps in between the bars because this is discrete data. Just to finish it off, we need to start labeling the axes. So this was frequency, and this was type of bird. And then you might want to give it a title. Birds in my garden. Or the garden. Okay, done. Question 7. Eve has these coins. So she's got a £2 coin, a £1 coin, 50p, 2 20s, a 5 and a 2 pence. Ola has these coins. She's got a £1, a 50p, a 2p and a 1p. Eve gives 3 of her coins to Ola. Now Ola has the same amount of money as Eve. Which coins does Eve give to Ola? Okay, let's see if we can work this out. Let's work out how much they've got each first off then. So Eve is starting with 2 plus 1, which is 3, plus 50p, plus 20, plus 20, plus 5, plus 2. That adds up to 3, 50, 90, 97. So Ola starts with £3 and 97 pence. Ola has a £1, 50p, a 2p and a 1p. So that is £1 and 53. Okay, so then after Eve gives Ola 3 coins, they should have the same amount. Okay, so how many coins does she give them? Well, if we can work out what the difference is between their 2 numbers and half it, then we'll know how much Eve gives to Ola. So what is £3.97 subtract £1.53? That is 7 subtract 3 is 4, 9 subtract 5 is 4, and 3 subtract 1 is 2. So the difference between their money is £2.44. So if I half that, £2.44 divided by 2, 2's into £2.44, 2's into 2 go once, 2's into 2 go twice, 2's into 2 go twice, so it's £1.22, isn't it? Okay, so I need to give, well, Eve needs to give Ola £1.22, and that will mean that they have the same amount of money. So if she gives the pound and the 20p and the 2p, that's £1.22, isn't it? Okay, and then they'll both have the same amount of money. Eve will have £2 left, and the 50 and the 20 and the 5p, making £2.75. And Ola will now have £2 and the 50 and the 20 and the 2 pence and the 1 pence, which is £2.75 as well. Okay, so how am I going to write that down? Oh, I need to write down in the answer box. So she's given her a pound, a 20p and a 2p. So the pound coin, the 20p coin and the 2p coin. Question 8. A dry cleaning shop has the following offers. So for a suit, a normal price is £12.50, and they've got a offer which says the first suit is normal price and the second suit is half price. And for dresses, the normal price is £9.75, and they're offering 3 for the price of 2. So we need to work out the total price of 2 suits and 6 dresses. Okay, so let's have a look at the suits first. Now the offer is first suit normal price, second suit half price. So we need to dry clean 2 suits. So the first suit is going to be £12.50, and then the second suit is going to be half of £12.50. So half of £12.50 is £6.25. So the suits in total are going to cost £5, £7, £18.75 for the suits. Okay, what about the dresses? So dividing up our working. Dresses are normally £9.75, but you get 3 for the price of 2. Now if I want to do 6 dresses, then that's 2 lots of 3 then, isn't it? So I'm going to get 2 lots of 3 for the price of 2. So my 6 dresses are going to be done for the price of 4 dresses. So in other words, I just need to work out what £9.75 times 4 is. So £9.75 times 4. Calculator paper. So let's just tap that in just to work out, make sure we don't make any mistakes. It is £39. Okay, so then the total price then is going to be the cost of the suits and the dresses together. So the total is going to be £18.75 plus 39, which is what? Well, 39 is £1 less than 40. So 18.75 plus 40 would be 58.75. Taking off £1 is 57.75. Or you could tap it into your calculator. Either way, you're going to get 57.75. Question 9. Carl has twin sisters. The sum of their ages. Question 9. Carl has twin sisters. The sum of the ages of Carl and his twin sisters is 39. In 4 years' time, the twins will be 18. How old will Carl be in 4 years' time? Okay. Now let's say that Carl is of age X and each of his twin sisters is of age Y. Then the sum of the ages of Carl and his twin sisters is 39. Tells us that X, Carl's age, plus 2Y, his twin sister's age, is equal to 39. So that gives us an equation in X and Y. And then we're told that in 4 years' time, the twins will be 18. So in 4 years' time, Y plus 4 is equal to 18. So I get a second equation there for Y. So if I know that Y plus 4 is equal to 18, then Y is going to be 18 subtract 4, which is 14. So I know his twin sisters now are 14. Okay, and then substituting that into my other equation, the one that's up here, x plus 2y is 39. If I know that x plus 2y is 39, and I now know his sisters are 14 each. So that means x lots of 2 lots of 14 is equal to 39. Well, 2 14s are 28, so x plus 28 is equal to 39. And then subtracting 28 off both sides gives me x is equal to 11. So that means Carl must be 11. The question says, though, how old will Carl be in 4 years' time? He's going to be 4 years older than this, isn't he? So Carl will be 11 plus 4, so that means he's going to be 15. Question 10. One of the angles in a triangle is 60 degrees. Tick a box for each statement. Right. The triangle is equilateral. Well, that could be true, couldn't it? If you had a triangle, an equilateral triangle, 60, 60, and 60. Yeah, so that is possible. But you could also have another sort of triangle where that one was 60 and these two were something else. They might be 70 and 50, mightn't they? So you could have an equilateral triangle, but you could also have another angle that isn't. So I'm going to tick that it might be true. Okay. The triangle has at least one other acute angle. At least one other. Okay. Is it possible that neither of them would be acute? So if that wasn't true, then there must be if that statement wasn't true, then both of the other angles must be not acute. They must be obtuse. So they must be bigger than 90. So that cannot be true. So it must be true that the triangle has at least one other acute angle. That has to be true. The triangle is right angled. Is that a possibility? Could I have 60 at the top and 90? Yes, I could. I could have a right angled triangle where I had 60 there and 90. Well, that means this one down here would be 30. That's totally possible. But you can see there are other options, so it might be true. And then the last one is the other two angles are each less than 60. And again, if one of them is 60, then we have to share out 120 between the other two angles. So if one is less than 60, the other one has to be more than 60, so that cannot be true. So it cannot be true. Question 11. Which one of these numbers has exactly 2 factors? In other words, which one of these numbers is prime? Okay, now every number you can divide by 1 in itself, but if it has any other factors other than 1 in the number itself, it can't be prime then, and we'll have more than 2 factors. Now 6 I could write as 2 times 3, so that one is not prime. 7 I can only write as 1 times 7, that is the only one I can do. 8 I could write as 2 times 4, so that one is not prime. And 9 is a square number. I can make it by multiplying 3 by itself, so that one is not prime either. The only prime there is 7. Question 12. Work out the square root of 7.5 squared plus 18 squared and circle your answer. Okay, this is clearly a job for your calculator. So let's get the calculator out and type in the square root of 7.5 squared plus 18 squared. Now, if you've got a nice calculator like this one, you can type it in exactly as is on the screen. Press equals and it will tell you the answer, which is 19.5. That one. (13a), some more calculator work. Use your calculator to work out the exact value of 18,953 times 437 divided by 11. Now this is written as a quotient. You could just use the fraction key to write it down exactly as it appears on the screen. I think that's what I'll do here. So hit the fraction button first, and that gives you space to write in your 18,953 times 437. Then press the down button and then type in the 11. Okay, done. So let's press equals and we get what? 752,951. Okay, part B says use approximations to one significant figure to check if your answer to part A is sensible. Okay, so approximating like this is quite a good way of just double checking your work, because you can do it quickly in your head. So if I was to round off each of those numbers to one significant figure, I'd be rounding that one off after the first digit. It's got an 8 after that, so I'd be rounding up, wouldn't I? So my first number is going to round up to 20000. Remember, your rounded off number has to be of the same magnitude as your original number, so I can't just write in 2 and say that's a good approximation to 18,000. If someone owed you 18,000 and said, let's just round it off to 2, you wouldn't be very happy, would you? But 20,000 is an approximation to 18,000. Then let's multiply that then by, what's this next number rounded off then? So rounded off after the first significant figure. My next digit is 3, which means I need to round down. It's going to stay as a 4 then, isn't it? So it's going to be times 400. And then divide all that by 11. Well, 11 rounded off to one significant figure. Round off after the first digit. The next digit is 1, which means I round down. I'm going to round that off to 10. Okay. So what I'm going to do is I'm going to cancel that 10 into one of those zeros on the end there, and I've got 2 times 4, which is 8, and then I've got 1, 2, 3, 4, 5 zeros to add. 1, 2, 3, 4, 5 zeros. So my approximation comes out to 800,000, and my original answer was 752,951, which is 800,000 to one significant figure. So I'm going to say yes. My answer is sensible. I don't know if you have to write that down. It's not really clear, but there we go. I've done it now. Question 14. Chris sells lawnmowers. The table shows the number he sold each quarter for 3 years. So I can see he's got sales for 2016, 15 and 14 there, and they're divided up into the 4 quarters of the year. So a quarter might be 3 months. So the first quarter would be January, February, March. The second quarter is April, May, June, and so on. It's just a handy way to divide up a year into different sections so you can look at it into more detail. In which year did he sell the most lawnmowers? Now, to work that out, I need to total these up, don't I? I'm just going to create a total column on the end. Okay, and then so 17, 64, 50 and 5. I think it's easiest just to tap these into a calculator nice and quickly. So 17 plus 64 plus 50 plus 5, what does that come to? That's 136. Okay, then I've got 9 plus 72 plus 61 plus 1. That comes to 143. And then 2014, we've got 19 plus 58 plus 53 plus 2. That's 132. Okay, so we can see that the year he sold the most was that one there, which was 2015 then. 2015. Now it says you must show your work in here. I have done, really. I've shown it up there. That's good enough. It doesn't have to be in this space, and if you've got a diagram or a table and you prefer to work on the table, it really is no problem. You can just put it there. Okay, so 14b, he uses the table to decide the number of lawnmowers to stock each quarter. At the start of which quarter should Chris stock the most lawnmowers? Circle your answer. Okay, so where are the numbers the highest? Okay, well in the first year, quarter 1 had the highest number of lawnmowers, didn't it? And in the second year, again, it's the quarter 2 which has got the highest, and in 2014 it's also the highest. So quarter 2 sells the most lawnmowers. Makes sense when you buy a lawnmower in spring, ready for the summer. So I'm going to say quarter 2. It needs the most lawnmowers ready to start selling in quarter 2. Question 15. In a test, section A has 80 marks and section B has 120 marks. Ria scores 55% in section A and 70% in section B. To pass, Ria needs a score of 65% of the total marks. Does she pass? You must show your working. Okay, so we need to work out how many marks she scored in each section, add them together, and then work out what percentage that is of the overall paper. So let's start with section A. Section A has 80 marks and she scored 55% of that. So how much is 55% of 80? So what we're doing, what is 55% of 80? That would be 0.55 times 80, using 55% as a multiplier. Tap that into the calculator. So 0.55 times 80 tells me she scored 44 marks in section A. So this was in section A. Okay, what about in section B? She scored 70% and section B was made up of 120 marks. So it's 70% of 120. So 70% as a multiplier would be 0.7. 0.7 times 120. Again, time for a calculator. 0.7 times 120. That's equal to 84. So then our total mark then is going to be those two added together. So 44 and 84 added together. 4 and 4 is 8. And 4 and 8 is 12. So 128 marks. Okay, is that enough to pass? So the total test was out of the two sections. So total marks available is going to be 120 and 80, the two sections added together. So there were 200 marks available and she got 128 marks. So she's got, so total percentage is going to be 128 out of 200. Now if you tap that into the calculator, 128 divided by 200 is going to give you it as a decimal of 0.64, and 0.64 as a percentage is 64%. Now she needed 65%. Oh dear, dear oh dear Ria, you've missed it by 1 mark, or 1 percentage point I should say. So has she passed? No, Ria has not passed. And that is the sad truth of the matter. You might not pass by 1 mark, so make sure you do lots of revision for your maths exam. And make sure you do lots of past paper practice. Don't be a Ria. Question 16. A wheel is made of a circular rim and 8 spokes as shown. Now we're told that the length of each spoke is 37 centimeters. Work out the total length of the rim and the spokes. Okay, so we know that this is 37 centimeters. That's like the radius of this circle, isn't it? So then the total length of all the spokes and the circular rim is going to be, well, you can have your 37 centimeter spoke times 8. That will give you all the spokes, won't it? So the length of the spokes is going to be 37 for 1 times 8. Tapping that into the calculator, 37 times 8, that gives me 296 centimeters altogether. 296. And then we've got the rim, haven't we? Now the length of the rim, that's like the circumference of the circle, isn't it? Now the circumference of a circle is equal to pi times the diameter, or you can also write it down as 2 pi r. Now I'm going to write it down as 2 pi r this time because I've got a radius rather than a diameter. The radius is 37. So it's going to be 2 times pi times 37. Okay, now if you've got a decent calculator like this one, you've got a pi button down the bottom there, so we can just type that straight in. So 2 times pi times 37 comes out to be 74 pi. I'm going to leave it like that for now because I haven't quite finished, have I? So then the total is going to be 74 pi, the rim, plus 296, which is all the spokes. So bringing back up my calculator and adding on 296 to my answer gives me 528.47 and a bit. I'm going to round that off. Just going to write down 528. Normally you give answers to 3 significant figures, so it's perfectly acceptable to just throw away that decimal part and write down the first 3 digits. So I'm going to write down it is 528 centimeters. Question 17. Here is a formula to convert degrees Celsius to degrees Fahrenheit. So Fahrenheit is equal to 1.8 times a Celsius plus 32. Now this is useful if you ever go to somewhere like America. All the temperatures out there are given in Fahrenheit rather than Celsius. So it might be handy to be able to convert between the two. So if F is the number of degrees in Fahrenheit and C is the number of degrees in Celsius, show that minus 40 degrees Celsius equals minus 40 degrees Fahrenheit. Oh, okay. Well, let's try that out. So let's start with one side of it. So let's say if F equals, now let's start with C because this formula is in terms of C. So let's C equal minus 40, then F is going to be 1.8 lots of minus 40 plus 32. 1.8 lots of minus 40 is what? 1.8 times 40, so that's going to be negative 72, minus 72 plus 32, and minus 72 plus 32 is indeed minus 40. Okay, so we've shown it. And part B says the temperature is negative 15 degrees C. Nick says because the temperature is negative in Celsius, it must be negative in Fahrenheit. Is he correct? You must show your working. So basically we need just to sub this new value in. So if C equals minus 15, and try the calculation again and see if that is the case. So F then is 1.8 times C, 1.8 times minus 15 plus 32, wasn't it? 1.8 times negative 15 is negative 27. And then if I add on 32 to that, I'm going to get positive 5. So in this case, Celsius is negative and Fahrenheit is positive. So Nick is not correct. He is not correct. Question 18. Here are 5 cards. They're labelled 1, 5, 7, 9 and 11. One of the cards is removed. The mean of the numbers on the remaining 4 cards is 6. Which was removed? You must show your working. Okay, so if I remove a card and only have 4 cards left and the mean is 6, then the total on those 4 cards is going to be 4 times the mean, isn't it? Because that's how you get a mean. You add up all the numbers and you divide by how many you've got, and that tells you the mean. So if I times the mean by the number of things I've got, it tells me what the total is on all 4 things, and 4 lots of 6 is 24. Now currently those cards add up to, what do they add up to? 1 plus 5 is 6, plus 7 is 13, plus 9 is 22, plus 11, 32, 33. They add up to 33. So if I want to reduce them from 33 to 24, I need to subtract 9. Okay, so 33 subtract 24 is 9. So I need to remove the 9 card. The 9 was removed. Okay. Question 19a. Divide 120 in the ratio of 1 to 4. Okay, now when we're dividing into a ratio, we need to take our ratio, our 1 to 4, and add the 2 parts together. That means that we're dividing our number into 5 parts. Okay? So we're dividing the number into 5 parts. Now what is the value of each one of those parts? We can work that out by taking 120 and dividing it by the number of parts. 5's into 120. 120 divided by 5 is 24. Okay, so each one of those parts is worth 24. So if I then go back to my original ratio 1 to 4 and multiply each part by 24, I'll know how much each part is worth. So 1 times 24, that's easy, that's 24. And the other one, 4 lots of 24, is 4 times 24, 96. Okay, so my answer is 24 and 96. It's always a good idea just to double check by adding those together. I can see that they add up to 120. So that's good. Right, now part B says, write the ratio 7 to 4 in the ratio of n to 1. In other words, I need to divide. If I want to make that bit 1, I'm going to have to divide both sides by 4, aren't I? Okay, now, obviously, 7 doesn't divide by 4, so it's not going to give me a nice number. I'm just going to write it like this, 7 over 4. That's good enough. So 7 over 4 to 1. Some people don't like fractions, but really it makes life easier for you. 7 over 4 to 1. Now I could write that as a decimal. That is, what, 1.75? But it doesn't tell me I have to write it as a decimal. So I'm just going to leave it like that. Question 20. In 2015, Han was paid £1,350 per month. In 2016, he had a 2% increase in his monthly pay. He worked 37.5 hours per week, and he worked for 47 weeks. Work out Han's average pay per hour in 2016. Okay, we've got a few steps to do here. So first off, let's work out how much money he earned per month in 2016. So we had a 2% increase on the previous month. So we need to do a percentage increase, don't we? So his original value was 1350. His final value was what we're trying to find. And the multiplier, if I start with 100% and I'm adding on 2%, then that means I've got 102%, which as a decimal is 1.02. Okay, so I want the final. I tend to use this FOM triangle for working out how to do this. Final, original, multiplier. So, covering up the thing I want to find the F. So my final is equal to original times multiplier. Final equals original times multiplier. In other words, I need to take 1350 and multiply it by 1.02 to find the monthly amount. What's that then? Calculator, what is 1350 times 1.02? It is 1,377. Okay, so that's his monthly amount. Now, we're told that he works 37.5 hours a week for 47 weeks. And so, okay, so what do we need to do now? So we know he's been paid 1,377 per month. I think we need to find his yearly salary now, don't we? So to work out what you've got paid over the course of the whole year. So for whole year, he's going to be paid that 1377 12 times, isn't he? Once per month for 12 months. So that gives me, answer times 12, 16,524. 16,524. So that was his yearly salary. Now, we know he worked for 37.5 hours per week for 47 weeks. So the total hours he worked, so the total hours he worked are going to be those two numbers multiplied together, then, aren't they? 37.5 times 47. 37.5 hours a week for 47 weeks. Okay. You don't work every single week. You get holidays and things, which is why we still pay him for the full year when he's only worked 47 weeks. Everyone needs a holiday. So 1,762.5 hours. 1,762.5 hours worked. So his total pay for the year was 16,524, and he's worked for 1,762.5 hours. So his pay per hour, so his hourly rate, is going to be the amount he earned in total divided by the number of hours he worked. Okay, so again, just tap that into the calculator. 16,524 divided by 1762.5. Now that gives me 9.375 with the dot on the top. It's reoccurring, isn't it? So I'm going to round it off to three significant figures. So I'm going to round off after that 7, which means I need to round up because the next digit is a 5. So I'm going to write that down as £9.38. So £9.38. Question 21. An experiment is carried out 200 times. The possible outcomes are K, L, and M. Complete the table. Okay. So we've got our partially completed table here. So the number of frequencies should add up to 200 because there was 200 trials. So taking away 84 and 54 from 200, what's that? 200 subtract 84 subtract 54 gives me 62. So M should have occurred 62 times. Now you find relative frequency. Relative frequency is given by successful trials divided by total trials. So to work out the relative frequency of each one of these, you're going to have to divide each one by 200. Now you can see that's what's been done with the first one. 84 divided by 200 is 0.42. 54 divided by 200 is 0.27. And 62 divided by 200 is 0.31. Now part B says, altogether the experiment is carried out 500 times. How many times would you expect the outcome to be K? Okay, now expected outcomes is going to be the relative frequency multiply by the number of trials. In other words, K had a relative frequency of 0.42, so 0.42 times the 500 trials. Just type that into the calculator. 0.42 times 500. So we would expect to get 210 outcomes to be K in this experiment. So 210. The table shows information about the UK and Germany. I've been given the population and area of both countries. Germany's got more people, but it's also got a bigger area. Population density is given as population divided by area. We're asked to compare the population densities of the UK and Germany. Okay, so let's work out what their population densities are first. So population density for the UK is going to be 64 million divided by 95,000. Okay, I'm just going to get rid of some of these zeros. Those three cancel out with those. So I've got 64,000 divided by 95. Just makes it a bit easier to type into the calculator. So 64,000 divided by 95 comes out to be 673 and change. So let's just round that off to three significant figures. Let's call that 674. I suppose that's people per per square mile, isn't it? 674 people per square mile. So population density of Germany is 82 million divided by 140,000. So again, I can cancel those zeros off. Just makes it a little easier to type in. So what does that give me? 82,000 divided by 140. Again, I'm just going to round that off to three significant figures. So that's going to be 586. So there's roughly 586 people living in every square kilometre of Germany. So you can see that the UK has a slightly higher population density than Germany then, doesn't it? So I need to compare these two. So I'm going to say that UK has a higher population density than Germany. Job done. Question 23. Which one of the following is discrete data? Circle your answer. Okay, so if you didn't know this already, there are two types of data that you can get: discrete data and continuous data. Discrete data is data that has particular states it can be in. So it could be just all whole numbers or a particular number. Continuous data could be any value between a given range. So if you think about the mass of a television, that could be any number. Time taken to deliver a television could be any number. Time is continuous, mass is continuous. Height of a television mast, that is continuous as well, and numbers of televisions sold. Now that is the discrete one, okay? Whilst you could have a mass of, I don't know, 25.36 kilograms and a time to be delivered in a fraction. You can't have a fractional number of televisions sold. You sell a television, or you don't sell a television. Not many people go up and buy a part of a television. So number of televisions sold is the discrete data item. Describe fully the single transformation that maps triangle A onto triangle B. Now B is an equal version of triangle A, so it's an enlargement with a fractional scale factor because it's got smaller rather than bigger. Now notice this question is worth 3 marks. We need to give 3 pieces of information in order to get all the marks for this question. Now the first mark you'll get from just writing down the type of transformation is. So just writing down the word enlargement will get us the first mark. The next 2 pieces of information I'm going to get is for the marks I'm going to get for the scale factor and for the center of enlargement. Now to work out the scale factor, you just need to find 2 similar sides, or 2 matching sides on your shape, and then divide one by the other. So if you look from here to here, it's 1, 2, 3, 4, 5, 6 squares, whereas this one is 2. So the scale factor then is going to be 2 divided by 6, or a third. So scale factor 1/3. And center of enlargement you can find using ray lines if it's not obvious. So find pairs of matching points on your object and image and draw a line through them. So there's one. There's my first ray line. Tops of the triangles. Tops of the triangles are here. Second ray line, and there's another one here. Two's normally enough, but let's just do one for luck. You'll find that they all kind of converge on one point, and that will be your center. So here, that's the center of enlargement there. So for the final mark, we just need to mention where the center is. So center, what's the coordinates of that? 5, 1. So enlargement scale factor 1/3, center 5, 1. 3 marks. The graph shows information about prisms with the same volume. So we've got a kind of a strange looking graph here with length on one axis and area of the cross section on the other. So as length increases, area of the cross section decreases and vice versa. Give one example to show that the volume is 24 centimeters cubed. Okay, so let's just pick any value on here. So the volume of a prism is given by its cross-section sectional area times its length. So we basically need to take a point on this curve, work out the two values and multiply them together, and that should give us the volume. So let's take this point here on the graph because it's got nice easy points to read. So look, reading down from there, I can see that the area is 6, and reading across the length is 4. So taking my area of 6 and my length of 4 and multiplying them together, you can see that does give 24 cubic centimeters. Right, so part B says the diagram shows a prism with volume 24 cubic centimeters. The height of the triangular cross section is h. Work out h. So I know that the length of this prism is 5. So using my graph, I can then work out what the cross-sectional area should be. So coming back up to the graph. So length of 5 is, let's just get my ruler out. Reading across from 5 to the graph. Pick a different color. And then reading down. That gives me a cross-sectional area of 4.8 centimeters squared. So given that the cross-section is equal to 4.8 from the graph, then I know that the area of a triangle is going to be half base times height, and in this case the cross section is the area, so it's going to be a half times the baseline, which is 6, times the height of the triangle that I'm looking to find. So what can I do here? I can multiply these. Half of 6 is going to be 3, isn't it? So just simplifying that first, that's 3h is equal to 4.8, and then cross multiplying the 3 over there to find what h is. H is going to be 4.8 divided by 3, which is 1.6. So it's going to have a height of 1.6 centimeters. A ball is thrown from a height of 15 meters. It bounces to a height of h1 and then h2 as shown. Okay, so here's my ball, it bounces and then bounces. Okay, so h1 is 3/4 of the original height. So h1 is going to be 3/4 of 15, which is 15 times 3/4. So 11.25. Okay, and then Jack expects H2 to be 3/4 of H1. Work out the value of H2 that he expects. Okay, so then H2 then, if it's 3/4 of H1, we just worked out, let's write that a bit nicer, of H1, and we just worked out that that was 11.25. So what is 3/4 of that? So again, divide by 4 times by 3. That gives me 8.4375. Okay, so in fact H2 is 2/3 of H1. How does this affect the answer in part A? So rather than multiplying by 3/4 like we thought, we're now going to be instead multiplying by 2/3. Now, which is bigger, 3/4 or 2/3? Just from my knowledge of fraction, I know that this one is, the 3/4 is a bigger one. So I'm multiplying through by something that is slightly less than it was before. So if I'm multiplying through by a smaller fraction, then I think it's going to be lower than he expected. But anyway, I'm gonna work it out properly so we can compare our work anyway. So in fact H2 is 2/3 of H1. So we're going to work out what H2 is now, given that it's 2/3 of H1, which is 2/3 of 11.25, which is 11.25 divided by 3 times by 2, 7.5. So that is a little bit lower, because before we had it down as 8.4 and something, didn't we? So yeah, that is going down a bit. Okay, job done. Solve for lots of 3x minus 2 is equal to 2x minus 5. Okay, so let's just write down what we've got to start with. Probably the easiest way is to multiply out the brackets. So 4 times 3x and 4 times minus 2, which will give me, funny weird pen, which gives me 12x minus 8. And then moving my 2x over here and my minus 8 to this side. So change sides, change sides. So 12x, if I move the 2x to the left, it's going to become minus 2x, 12x minus 2x. And I've got negative 5 already there, and if I move the negative 8 to the other side, it's going to become positive 8. So 12x minus 2x is 10x, and negative 5 plus 8 is 3. Give me x is 3/10, or 0.3. I'm just going to write down 3/10. Here's my answer. Work out the next term in this quadratic sequence. Okay, let's start off by looking at the jump between the various numbers. So from 5 to 8 is 3. Difference between 8 and 14 is 6. And the difference between 14 and 23 is 9. So you can see that the common difference here for each of these is 3. It's going up in 3s each time, isn't it? So the next amount it's going to jump up with is going to be another 3. 9 plus 3 is 12, and 12 more than 23 is going to be 35. So the next term in this sequence is going to be 35. And work out the size of angle x. So you've got a right angle triangle, and I've been given 2 sides and I want an angle, so it's clearly going to be trigonometry. Now you can remember which ratios you want to use, whatever way you like. I use SOHCAHTOA. It's just a handy way of remembering each of them. So what have I got here? Let's label up the sides. I've got my angle here. So this is the hypotenuse, it's the longest side. Relative to my marked angle, 3 is opposite and 7 is adjacent. So I've been given the opposite and I've been given the adjacent. So the ratio I want to be using then is going to be this one on the end here, tan. So then I'm going to write down what that ratio is. tan of an angle is going to be my opposite over my adjacent. So subbing in from the diagram. So I haven't got theta, I've got x. So tan x equals, opposite is 3, adjacent is 7. So if I want to find x, I'm going to use the inverse tangent button on my calculator. So that's shift tan 3 divided by 7. So my calculator is saying 23 and change. I'm going to write that down to 1 decimal place. 23.2, and the unit is degrees, isn't it? 23.2. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.